Hey everyone, today we are going to solve LeetCode problem number 129, sum root to leaf numbers. In this problem, we are given a root of a binary tree, which is containing digits from 0 to 9 only. As shown in this example, this is a binary tree given to us, and every node is a digit from 0 to 9. And what we have to return is, we have to return the sum of all the path from root to leaf. Let's say one path is like this, 495. Second path is 4, 9 and then 1. Third path is 4 and 0. Something like this. So the sum of these numbers, what is that number? 1026. Yeah. So this we have to return. Okay. And this is an important constraint that every number is from between 0 to 9. It means that while making this number, whole number 495, what we can do is, firstly we have captured 4. Then we are when we are reaching 9, what we can directly do, we can directly multiply 4 with 10 and add the next number, and multiply 10 the previous captured number so far, and add the current number, something like this. And what we have to return is the sum of root to leaf numbers. Task is generated, the answer will fit in 32-bit integer. Okay, a leaf node is a node with no children, and our constraint is that we have to start from root and we have to reach till leaf. So our path will like this, starting with 4 and ending with 4, 5, 1 and 0. So we have 3 paths here, and 3 number we will form by doing recursion from root to leaf, and then we are going to add those numbers, and that will be our answer. So how we are going to do that? Uh, it's going to be a similar question to to finding the leaf node, something like that. So we are going to start from root and doing the recursion, making 2 recursive call in both directions. And when we are stopping the recursion call, either it is a terminating case, let's say root is null, or we are encountering a leaf node. In those 2 cases, we are going to terminate the case. If it is a null, then we can directly return. If it is a leaf node, in this case, we will capture our answer. But we have to make sure that while passing the call to further, we have captured all the numbers so far. So we are going to start our recursion with 4, moving to the left and right. Firstly, we will move to the left. We will coming to 9, and our number so far is 49. Here the number was 4. And then we are again coming to left, which is 5. The number is 495. Now our two cases, the one case is leaf, the second case is null. So the leaf case will run. It means this is a leaf node, and this answer we have to capture in our sum, global sum. So sum plus equal to 495. After that, we'll return back from this call, and we are coming to 1. We encounter that 1 is also a leaf node, and the number so far is 491. So 491 will also be captured to our answer, and then we will again back from this recursion call, and we will go to 0 node. 0 node is also a leaf node, so but the number at the 0 is 4 and 0. So in this way we can calculate our sum. So how do we write the recursive function for that? Let me write a code for you. Let's write a function, solution function, where we are passing the root node and the number so we have generated so far. And to calculate sum, I'm taking a global variable. So what are our terminating cases for now? The first case is root is null, and the second case is if the root is leaf. This is going to be our code. If the root is null, we can directly return, okay, we are not returning null, we are just directly returning from this function. If the root is a leaf, then we have to do something, we have to capture our number to the sum. So what is our number? So number initially it was, let's say if we are passing 0, so at the root, if the root is not a leaf node, when we are coming to the left, let's say 4 0 1, when we are coming to the left is a leaf node, and the number so far is number we are getting from previous call, and the current number. So from the before the processing of this call, we can update our number so far. So let's update our number so far. Number so far is equal to number so far into 10, because every number is a single digit. Number so far into 10 plus root dot value. In this way, we have calculated our number so far. If it is a leaf node, then our number so far will be added to sum. Sum plus equal to number so far. If it is not a leaf node, then we can pass this number to the further call on the left and right side. So let's say when it is a root, initially we are making the solution call with the root and the number as 0. So when we are coming to root, we will update our number so far. Number so far is 0 into 10 plus 4. Number will be 4. And then we will see whether it's a leaf node or not. It is not a leaf node. It means we are not going to do anything. We will just make subsequent call. Call on the left side with number so far as 4. Call on the right side with number so far as 4. In this way, we are iterating over each node, and whenever we are encountering the leaf node, we are capturing our answer. Okay, I hope you understood the approach. Let's start writing the code for this function. Initially, we are going to have a sum 0. We will be calling our solution function with root and initially as a number so far as 0. And in the end, we will return our sum, which is our global variable, and we are updating whenever we are encountering leaf node. So now write our solution function private void solution tree node root and int number so far. What are our terminating cases? If root is equal to null, you don't have to do anything, return null. And if it is a leaf node, root dot left equal to null and root dot right equal to null, it's a leaf node. In this case, we will be adding our number so far in the sum plus equal to number so far, and we also have to add the current root to the number so far. Let's say when it is root, we are passing 0, so we have to add root. So number so far is equal to number so far into 10 plus root dot value. Now we can move to the left and the right with this current number. Solution root dot left number so far, solution root dot right number so far. Let's try to test over sample test cases. Oh, we don't have to return null from here. It's a void return type. Sample test cases are passed, submitting the problem. It got submitted successfully. Hope you understood the problem. Thank you guys. Bye bye.